In the previous video, we saw how to use a spreadsheet to calculate a Riemann sum, but it was a very inflexible setup. If we wanted to modify the problem slightly, we would basically have to remake the entire spreadsheet. In this video, we're going to see how we can set up our spreadsheet to make it more flexible. You might have noticed in the previous version that we used the width of the subintervals in multiple places. This gave us the spacing between the points x sub I star, and we also needed that value as the width of the rectangles when calculating the areas. In both situations, we manually included that value in the formula. This is a sign that we have an inefficiency in our setup. If we think about Riemann sums in general, we can see there's always going to be a collection of input parameters. We will always need to indicate the interval from a to b and the number of rectangles that we intend to use. And this was the information that went into calculating the width of the subintervals, which is also the same as the width of the rectangles. We want to automate this part. We will use the same problem as before. We want to estimate the area under the curve y equals 4 minus x squared on the interval from -1 to 1 with 4 rectangles using the left endpoint for the height. We'll clear the entire spreadsheet and start from scratch. This time, instead of starting off with columns of data, we're going to make space for some parameters. The first column will be the labels, and the second column will be the values. We currently have 3 input parameters: a, which is the left endpoint of the interval, b, which is the right endpoint of the interval, and n, which is the number of rectangles. For our problem, we have a equals -1, b equals 1, and n equals 4. In our Riemann sum calculation, we're going to need the width of the subintervals, which can also be calculated from these parameters. It will be convenient to have a cell that has this worked out for us so that our formulas will be simpler when we get to them. We'll leave a space below our parameters and add delta x. At this point, we want everything to refer back to the original parameters. This way, we can change the parameters and have the value update automatically. The formula for delta x is b minus a over n, which is the total width of the interval divided by the number of subintervals that we need. Make sure you use parentheses here because otherwise order of operations will kick in and give us the wrong value. We can see that if we change the values of a, b, and n, the value of delta x correctly updates. For example, if we wanted the interval from 0 to 1 with 10 rectangles, we would have delta x equals 0.1. But let's go back to the original problem. We're now going to recreate the columns from the last video, but we'll try to reference the parameters instead of hard-coding the values into the formulas. The first column is just our index column again. The next column was the values x sub I star, which represented the points at which we evaluate the function. The first value is the left endpoint of the interval, which is one of the parameters, so we set this cell equal to the value of a. From here, we want the cell above plus delta x. When we do this, we need to be careful about how we reference the value of delta x. The default for the spreadsheet is to maintain the relative positions of cells in the formula. If we select the value of delta x and just autofill down, we'll see that this doesn't work. And we can see why if we look at the formula. The cell referencing delta x moves down as the cell gets copied downward. To prevent this from happening, we use the $sign in front of the positions that are absolute instead of relative. Since we don't want the cell to ever move, we'll put a $sign in front of both the b and the 5. And when we autofill downward, the formula remains intact. The next column is f of x sub I star, which makes no direct reference to delta x, and so the same formula that we used last time will work. The column after that is the area of the rectangles, which is f of x sub I star multiplied by delta x. Once again, we will use $signs to fix the reference to delta x. Lastly, we can sum the column to get the result. We'll put the result on the left with the other calculated values so that all of our information is in one place. We have the same values we had before, except that we can now update the values more quickly. If we wanted to use the interval -2 to 2 with 4 rectangles, we just need to update the values of a and b, and everything else happens automatically. If we wanted to change the value of n to 100, we would still have to manually manipulate the columns so that they're the correct length. But at least this time, there are fewer ways for us to make mistakes. When we autofill down, the value of delta x has already been updated for us. If we wanted to change the formula, we could change it at the top of the f of x sub I star column and autofill downward. It's not too difficult of a change, but it still must be done manually and still must be filled downward. In the next video, we'll see how to make this evaluate at different points in the interval.